This is the brief on the mathematical identity and visual interpretation of tensor components. You know, tensors can seem pretty abstract, right? But they're a lot easier to wrap your head around when you see how their strict mathematical rules connect directly to what they actually do physically. First, let's talk about the math. There are these two key identities that really clean things up. The symmetric or stretching part of a purely rotational tensor, it's zero. It just vanishes. And the same thing happens with the rotational part of a purely stretching tensor. It shows these two actions are fundamentally independent. Second, how does this look visually? Well, this is the cool part. Any tensor's transformation can be broken down into two distinct actions. The symmetric part is basically a stretch or squish, and we can visualize that with an ellipsoid shape. Then you have the anti-symmetric part, which is just pure rotation, represented by a simple circular arrow. And finally, here's where it all clicks together. The full, sometimes complex transformation that you see from the whole tensor, it's literally just the combination of those two simpler visuals, the stretching ellipsoid and the rotational arrow working together. Grasping these concepts gives you a clear roadmap from some pretty intimidating algebra right into a tangible physical intuition.